Everyone, this is the first half of our chapter review. Your test is upcoming this week on Wednesday and Friday. On Wednesday's part of the test will be the chapter 2 material, which will be covered in this video, and on Friday's part of the test will cover chapter 8's material, which will be covered in the next video. The problems that you're seeing in this video, I uploaded a blank set of them to Polaris in case you want to check those out. Print them out and fill them in as we go. For the test itself, you will be allowed to use a graphing calculator on both portions of the test, but know that many of the problems will ask you to solve for things algebraically, and you will need to show your work for every problem in order to receive full credit. So pay close attention to the take-home quiz solutions that were posted, as well as the video itself as we go through it today, and you can see exactly what is expected of you. As far as formulas go, I know that question has come up a couple times. No formulas will be provided to you on this test or any other test this year. So if there's a formula you feel like you need to know, for example, like the distance formula or the midpoint formula, make sure you have that memorized prior to the test. Okay, let's get started on our chapter 2 problems. Question number 1, given the points -5, 3, and 4, -6, find the distance between the points and the midpoint. So let's start with part A. We're going to use our distance formula. Distance formula is x2 minus x1 squared, y2 minus y1 squared with addition between them. So the distance between points P and Q would look like 4 minus -5 squared and -6 minus 3 squared. I'm going to simplify under the radical. 4 minus -5 gives me 9 squared, which is 81. And then -6 minus 3 is -9 squared, also 81, which gives me 162. Make sure if you have a radical, you break it down. This one breaks down into 2 and 81. That's actually how we got 162. It was 2 square roots of 81 when we added them together. And that gives me 9 rad 2 would be the final answer, and you could just label this with units. Do not give me a decimal answer for that or you will lose points. Make sure your answers are always exact. For part B, we need our midpoint formula. Midpoint formula is x1 plus x2 over 2, kind of like an average of my x coordinates. Y1 plus y2 over 2, average of my y coordinates. So the midpoint for these two coordinates are -5 plus 4 over 2 and 3 plus -6 over 2, which is going to give me a -1/2 and a -3 over 2, and neither of those reduce any more than that, so we're just going to leave those as our final answers. Question number 2 on the test, find the value of x given that the point x8 is 6 units from the point -3, 4. So again, this is a distance problem. I'll write out my distance formula again. Oops. Writing the wrong formula in there. Let me erase that. Where'd my eraser go? There we go. Almost put my midpoint formula inside of my distance formula. Let's try that again. x2 minus x1 squared, y2 minus y1 squared. In this problem, we are given the distance. We know our distance, one point is 6 units from the other. So we're going to plug that in for D. And then I'm going to plug in my 2 points. My x's are x minus -3 squared and 8 minus 4 squared. We can simplify a little bit underneath that square root. X minus -3 changes to x plus 3 squared, and 8 minus 4 squared is just 4 squared, which is 16. Next, to solve for x, we're going to need to get rid of my square root. So to get rid of my square root, I'm just going to square both sides of this equation. 6 squared is going to give me 36. Then over here I have x plus 3 squared plus 16. Now one way you can solve this problem is you can FOIL, but you don't have to FOIL in this problem because you only have one x right now and it's already in this nice factored form for you. You can go ahead and just isolate this parentheses to solve for x. So I'm going to subtract 16 to the other side. That's going to give me 20 equals x plus 3 squared. Then I'm going to take the square root of both sides. So square root of 20, don't forget your plus or minus, that's very important here. And if I take the square root on the right, I'm just going to have x plus 3. And then finally, I'm going to subtract 3 to the other side. You can put this after the square root, or I like to put it in front of the plus or minus. I think it just looks a little cleaner, and that way it doesn't look like your number's underneath your square root. You actually have two answers here, -3 plus square root 20, -3 minus square root 20, but you can reduce that radical. Square root 20 breaks down into 4 and 5. So I can simplify this to -3 plus and minus 2 rad 5 are the values of x. That would give me points 6 units from the point -3, 4. Problem number 3. Here we are given 3 points A, B, and C. We want to know if these points are collinear or they make a type of triangle. So collinear, remember that means the two smaller distances add to the larger distance. An isosceles triangle, two distances are the same. Equilateral, all three distances are the same. And scalene, none are the same. In any case, for all of these, you need to find the three distances. So we're going to find the distance between points A and B, the distance between points B and C, and the distance between points A and C. Think of this problem as a proof. You must justify your work using these distances in order to answer this question completely. So make sure you show all of these formulas on your test. The distance between A and B, I'm not going to write the original formula out here again. We've done that a couple times. It's x minus x. So 3 minus -3 squared. And y minus y, 4 minus 2 squared. 3 minus -3 is 36 when I square it, plus 4 minus 2 is 2 squared, it's 4, and I get square root of 40, which does break down, but that's not my answer anyway, it's just for my work, so I'm going to leave it like that. Distance between B and C, x minus x, 1 minus 3 squared. And y minus y, -2 minus 4 squared. So we're going to get 2 squared, which gives me 4. -2 minus 4 squared gives me 36. Add them together. I get square root 40. So at this point, we can say it's definitely not a scalene triangle. Finally, distance between A and C, 1 minus -3 squared. And -2 minus 2 squared. I'm going to have square root of, it'll be 4 squared, so 16, plus another 4 squared, which will be 16, and that is square root of 32. Again, that breaks down, but not my final answer, so we're just going to leave it. You can say at this point it is not an equilateral triangle because all three are not the same. So these are either isosceles or collinear. We can say this is not collinear because we don't actually have two smaller distances. Actually, I'm not even going to write that. We have two larger distances. Square root 40 is larger than square root 32. So we don't have a situation where two smaller distances can equal a larger distance. So therefore, you must have an isosceles triangle. So let's just go ahead and write that down. So on a test problem like this, you'd get a point for that answer, but you'd get several points for the work itself to support that answer because that is your proof. So make sure, again, you're showing all the work for that. Okay, number 4, we need to calculate x and y intercepts. So review of those. If you want to find an x-intercept, you let y equal 0. And if you want to find a y-intercept, you let x equal 0. If I let y equal 0, my two y terms are going to disappear. And that's going to leave me with 3x squared minus 48 equals 0. And now we need to solve for x. I'm going to add 48 to the other side. Divide both sides by 3. That'll give me x squared equals 16. And then take the square root of both sides. Square root of 16 gives me 4. Don't forget your plus or minus. So you have x-intercepts at 4 and -4, and you can write it like that on the test. That's fine. If you wanted to write this as coordinates, you could say I have x-intercepts at the points 4, 0, and -4, 0. If I want to do y-intercepts, I let my x equal 0. Let me do that one in a different color. If I let my x equal 0, it's just going to eliminate this first term. And I'm going to put everything else in order, exponents descending highest to lowest, so that gives me a y squared plus 2y minus 48 equals 0. Here I have a quadratic, but I have two different y terms, so we need to factor. I need two numbers that multiply to -48 and add to 2. Let me set up my parentheses. Y in front of each. My two numbers that multiply to -48 and add to 2 are +8 and -6. If I set each of those equal to 0 with the zero product property, I'm going to have -8 and +6. Again, you can write those on your answer line on your test, or you can write it as the coordinates. When x is 0, y is both -8 and 6. Those are the points where this crosses the y-axis. Problem number 5. This is a test problem for symmetry. So make sure, again, you're showing all the work. This is a proof. This should be a 3-column proof. Testing for symmetry to the x-axis, the y-axis, and the origin. To test for symmetry to the y-axis, we substitute in -y. To test for symmetry to the y-axis, we substitute -x. And to test for symmetry to the origin, we sub in both -x and -y. If I put -y in for all my y's in this equation, that would look like -y to the 3rd equals x to the 5th minus x. Anything to an odd power is going to remain negative. Remember, anything to an even power will become positive when you plug these negatives in. And now we simplify compared to the original equation. On the right side, my equation matches, but on the left side, it does not. So it's safe to say this is not the same as the original equation, so there is no symmetry to the x-axis. To test for symmetry to the y-axis, we're going to plug -x in for all of our x's. So -x to the 5th minus -x. So I have y to the 3rd. That'll be a -x to the 5th, and then minus a negative here will be a positive x. Now, once it's simplified, I can say the left side looks the same as the original equation, but the right does not. So we say that there is no symmetry to the y-axis. Finally, symmetry to the origin, we plug in both. On the left, I have -y to the 3rd. On the right, I have a -x to the 5th and a positive x. And now, if you look, nothing actually matches my original equation. Everything has a different sign. So we can take one additional step, divide the whole equation by -1. So you're multiplying or dividing through a negative. And that will give me a positive y to the 3rd, a positive x to the 5th, and a -x, which is the same as my original equation. So we can go ahead and say yes there. So final answer is symmetry to the origin only. And again, your work is most of the points you would earn for that problem, your justification algebraically for that. Okay, problem number 6. Says find the standard form equation of a circle that has a center at -3, 7 and contains the point 1, 4. So I'm going to go ahead and write down our standard form of a circle, x minus h squared plus y minus k squared equals r squared. And there's 3 things you need to know. H and k is your center, which actually were given in this problem, h and k. And then r is my radius, which I'm not given. So we'll have to solve for that. To calculate the radius, if you are given a center point and any point on the circle, it is just your distance between those 2 points. So we're using our distance formula. We've done this a couple times already. X minus x, so 1 minus -3 squared. Y minus y, 4 minus 7 squared. So that will give me 4 squared, or 16, -3 squared, or 9, which is square root of 25. So my radius is 5 units. So now I can fill in my equation. X minus my h value, well, it's a minus -3, so it's going to be x plus 3 squared. Y minus my k value is 7 equals my r value squared. Don't forget to square that on the right. 5 squared gives me 25, and that's your final answer. Number 7 is another circle problem. Find the center and radius of the given circle. So the only thing you're going to have to worry about in this problem is really just getting it into that standard form we saw on the last slide. Once you have it in standard form, you can name the center and radius. You need to make sure you are doing the steps to complete the square here. So that's the big idea of this problem. To complete the square in a circle problem, we're going to first group together our like terms. So x squared minus 12x, y squared plus 18y, getting my x's and y's together, and then if you have a constant, you're going to move it over to the right side. From there, we're going to create a perfect square trinomial by adding a number onto my x's and y's. To find that number, you're going to take your linear terms of the number in front of your x or y respectively, -12 for my x's, half it and square it. If I half -12, I have -6 squared is 36. Same with my y's. Half of 18 is 9, squared is 81. If you add them to that side, you add them to the other side as well to keep your equation balanced. And from there, you have 2 sets of numbers that can be factored into a binomial squared. 2 numbers that multiply to 36 and add to -12 are -6 and -6. Instead of writing x minus 6, x minus 6, because we want standard form of a circle, we write x minus 6 squared. 2 numbers that multiply to 81 and add to 18 are 9 and 9. Again, we're going to write y plus 9 squared. And on the other side, we're just going to add all those like terms together. -7 plus 36 plus 81 gives me 110. From here, I can name the center and the radius. The center is the opposite of the numbers with my x and my y, so 6 and -9. The radius is the square root of the number on the right, so 110. 110, the factors of that are 11 and 10, or 55 and 2. None of those are perfect squares, so 110 does not break down. That's going to be your final answer. Number 8 is one of our line problems. Find the equation of a line parallel to 7x minus 4y equals 5 that goes through the point 6, -2. So what do we know about parallel lines? We know parallel lines have the same slope. If this problem said perpendicular, you would just do an opposite reciprocal slope, so it would have one extra step in it. To start, we need to find the slope of the line we're given. So I'm going to write that line down one more time. And because this guy is in standard form, I need to solve for y to get slope-intercept form and find that slope. So I'm going to subtract 7x to the other side, and then divide everything by -4. So that gives me y equals -5/4 plus 7/4 x. And the number in front of my x is my slope that I'm going to use. So I'm going to go to y equals mx plus b and just plug in 7/4. Remember, if this said perpendicular, you would have an extra step. If this problem said perpendicular, instead of using 7/4, I would use -4/7, the opposite reciprocal. From there, to find your y-intercept, you just plug in your x and y that you're given. I'm given a y value of -2 and an x value of 6. I can multiply those together. That's going to give me 42 over 4, which that reduces to 21 over 2, or you could just say 10.5 there because it's exact. And then from there, we're going to subtract 21 over 2 from both sides. So negative 2 minus 21 over 2 is going to be negative 25 over 2, or you could just say negative 12.5 because that's exact. So final answer, y equals 7/4 x minus 25 over 2. Make sure in your final answer you're only filling in m and b, you're leaving x and y. Number 9, another equation problem. Find the equation of a line that passes through the points 8, 4, and negative 10, 4. So anytime you're given 2 points and you need to find the equation of the line, the first thing you need to do is find the slope. Slope formula is, let me write this down again, y2 minus y1 over x2 minus x1. My y value from point 2 is 4, minus my y value from point 1 is 4, over negative 10 minus 8. The numerator gives me a 0. The denominator gives me an 18. Whenever you do the slope formula and you have a 0 in either the numerator or denominator, that's telling you you have a special case. If your 0 is in the numerator, your slope is 0. And you need to think about what kind of lines have a 0 slope. That tells you you have a horizontal line. And you need to write your equation as y equals a number. Now going back to the original points here, you can see the y value in each point is 4. So that tells me what my constant is. Y equals 4 is the equation of your line. Now the alternative to this special case is if you had a 0 in the denominator. If you have a 0 in the denominator, the slope is undefined. A common mistake there is people will say that the answer is undefined or the line is undefined, but that should never be the case. If you're given 2 points, you can always connect them and make a line. If you get an undefined slope, a 0 in the denominator, it tells you you have a vertical line, and your answer would be x equals whatever your x coordinates of your point are. If we didn't have one of these special cases, by the way, after you found the slope, you would plug the slope and one of your points into the equation like we did in the last problem and solve for that y-intercept. Number 10, the last problem here is going to be a graphing calculator problem. You're going to find the line of regression and then interpret the slope and y-intercept. So I'm going to load up my graphing calculator here. Okay, so we want to first enter our data in our calculator. To do that, we're going to hit Stat, Edit, and if you have data in there already, you're going to go up, hit Clear, and go back down. Up, clear, go back down. Assume that the first set of data you're given is your X's. Those are going to go to L1. So here that would be hours of studying. And then our second set of data is going to be our L2, our Y's, our dependent variable. So here I have hours of studying. Let's see, I have 0. No, I don't have 0. I have 1, 2, 3, 5, 7, 12, and 15. Then I'll arrow to the right and we'll get all of these grades in. 68, 71, 76, 83, 89, 92, and 100. Once you have your data in there, to calculate the line of regression, we're going to hit Stat, go over to where it says Calculate, number 4, and then just hit Enter as many times as you need to get your equation. So let me drag that over. There we go. Okay, so my equation for the line of regression is y equals, give it 3 decimal places if you're not told how to round, 2.134x plus 68.997. All right, so second part of this problem is to interpret, which means describe what the slope and y-intercept mean. So let's start with the slope. So the slope is 2.134. Slope in real life represents a constant increase or decrease. So this means, think of it as that over 1 right now. This means for every 1 hour of studying, our grade will increase by about 2.134 points or percentage. It's not specific here, so we'll say points. Y-intercept. Y-intercept is 68.997. Y-intercept in real life represents an initial value or a starting amount or a value of 0. So this, in this case, represents if you study for 0 hours, your grade would approximately be a 69. Okay. Now remember, this data is not perfect. It's close to linear data, but it's not perfect. So notice something interesting here. It says if we do study for 1 hour, we actually get a 68, or that one student studied for 1 hour and got a 68. So again, it's approximations, but this is the interpretation of the line of best fit, which would show the general trend in our data. Okay, that is the end of what you will see on Wednesday's portion of the test and the end of this video. To study, you guys should be looking back at the quiz solutions that have been posted. There is also a large set of questions. I think there's 48 or 49 questions total posted on Polaris. How you are to use those questions if you are an e-learner or you just want to study at home in the evening is find a problem on there. So start with the first problem, do that problem, and then scroll down to see the solution worked out. If you get the problem correct and you feel like you don't want to study it anymore, you can skip the next 2 problems that are similar and you can go to the next type of question. So you should at least probably try one of each of those on your own. Try the problem, scroll down to see the problem with the solution and check your work. And then if you feel like there's additional problems that you need practice on, you can always go back and do those. All of those problems are optional, as well as watching these videos, but you're at the end of this video, so good job you watched the first one. You do have a Math Excel assignment that is due Tuesday night by midnight. That's your review. Maybe some of you started it or finished it maybe even this weekend, but that assignment is due Tuesday night by midnight.